Hi, today we're going to be looking at foundation level GCSE. This is the Pearson Edexcel exam board, and we've got the paper 2 from November 2022. So this is one of the calculator papers. Question 1. Write the following numbers in order of size. Start with the smallest number. So the smallest ones are going to be the negative ones. Okay, so we're looking at these three, and the smallest is going to be the most negative. So the most negative is going to be minus 7. Then we're going to have minus 2. Then we're going to have minus 1. Then we've got 0, which would be in the middle. And we've only got one positive number. That's the 7. There we go. Question 2. Write 37% as a fraction. Well, 37% means 37 over 100. Okay. Question 3. Write down the 7th odd number. Okay, so odd numbers are numbers that can't be divided by 2. So 1 is the first odd number, and then 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 1, 2, 3, 4, 5, 6. That's the 7th odd number. Question 4. Change 53 centimetres to millimetres. Okay, well there are 10 millimetres in 1 centimetre. So if we're going from centimetres to millimetres, we're going to have more millimetres. So we want 53 times 10. So you can use your calculator for this one, but when we're multiplying by 10, we're just putting a 0 on the end. Question 5. Here are 4 cards. There is a number on each card. So we've got 4, 7, 6 and 3. Write down the smallest 4-digit even number that can be made using each card only once. Okay, so we've got to use all of these numbers. It needs to be an even number, so that means it needs to end in either the 4 or the 6. And we want the smallest one. So to make it the smallest, we want to have the biggest number, so the number at the front, to be the smallest digit here. So we're going to start with the 3. And then the next smallest is the 4. So we're going to have 3,400. Now, if we were going to make it the absolute smallest number, we'd go 67. But they want it to be an even number, so it can't end with a 7. So we're going to have to make it 3,476. The smallest even number we can make. And you might notice that although this is a calculator paper, we've got all the way up to question 6. And we haven't really needed the calculator. It's not really going to help us much. But hopefully we'll get to use it later on. So question 6. Here is a quadrilateral ABCD. It's a 4-sided shape. Measure the length of side AB. Give your answer in centimetres. So we need our ruler for this. AB. So make sure you start from 0, which might not be the end of the ruler. Might have to go in a little bit. And 1, 2, 3, 4.5. Okay. Then we've got part B here. Measure the size of the angle marked X. Okay, so I can't use my ruler for that. Instead, I'm going to need my protractor. So we can measure it either from this way round, or we can measure it along this line here. I'll show you that we should get the same answer whichever way we do it. So I'm going to start this way. So I line up one of the lines with the bottom line of my protractor, get the crosshairs right on the corner of the angle there. Now, because I'm measuring this angle here, I'm going to start with 0. So 0, 10, 20, 30, the outside numbers, all the way around, and it comes up to pretty much on 110 degrees. Now, just to show, if we measured it the other way from this side, we still get the crosshairs on here. line this up there, yeah, and on this line. Now, because we're starting here, we want to start from 0, we need to use the inside numbers. So 0, 10, 20, 30, 40, all the way round, and again, we get 110 degrees. So it doesn't matter which way round you measure it, you should get the same answer. Question 7. Miles writes down the distance readings from his car at the start and end of a journey. So it was 12,468 miles. At the end, it was 12,845 miles. Miles knows that the cost of petrol for this journey is 13p per mile. Work out the total cost of the petrol used for this journey. Give your answer in pounds. So first thing we want to do is work out how many miles we've got. So we want to start with the end number of miles. So we want actually I'll write it down here. We want 12,845 minus the starting miles. So this is going to give us the difference, the number of miles it's actually travelled. So now we can use the calculator. So 12,845 minus 12,468, get 377 miles. And it's 13p per mile, so we can multiply that by 13. And we get 4,901, but that's in pence, that's p. We want the answer in pounds. So there's 100 pence in a pound, so we need to divide that by 100. Or you can just put the decimal point where you think it should go, but if we divide by 100, we find the answer is £49 and 1p. Can we write that in here? That was worth 4 marks. Question 8. Sophia wants to hire a van. She uses this rule to work out the cost of hiring a van for a number of days. So the cost equals £45 times the number of days. Sophia is going to hire the van for 7 days. Work out the cost. Well, it's just going to be 45 times 7. And we can use the calculator again. £315. So nice straightforward one there for 2 marks. Question 9. The table shows information about the number of students who arrived late at school each day 1 week. So on Monday there were 9 students late, Tuesday there were 10, Wednesday there were 8, Thursday 6 and Friday there were 3. On the grid, draw a bar chart for this information. Okay, so you can draw a horizontal or vertical bar chart. Normally I'd draw a vertical bar chart. Generally that's what's expected, although you won't be marked wrong if you do a horizontal one, but you might find the graph paper is better set up for a vertical one. Although I think we've got a square here, so it shouldn't matter. Right, so what we need to do is we're going to have our days of the week going along the bottom. Days of the week, and we've got Monday to Friday. So that's 5 different days, but we've got 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12 squares. So 5 doesn't go into that evenly. So what I'm going to do is I'm going to give 2 squares for each day. So we've got Monday, Tuesday, Wednesday, Thursday and Friday. And we're not going to use this bit, that's absolutely fine. Now we're going to need our number of students going up the side. But we've got to work out the scale first. So what's the biggest number? We go up to 10. So let's see, can we fit them on if we just do one per student, so that'd be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, that fits on there. 0 at the bottom. I don't have to write all the numbers on. I might want to just write the even numbers on. Okay, so now we've got to do our plotting. So on Monday there were 9 students. So Monday 9, so 9's going to be halfway between 8 and 10. Draw a line across there. On Tuesday there were 10 students. So go across here. I'm going to do all my vertical lines at the end. You can do them as you're going along if you want to. Wednesday there were 8 students. So Wednesday 8, so we want a line from here to here. Thursday we've got 6 students. And on Friday 3 students. Friday's here. 2, 4, so 3 is going to be in the middle. And then we draw our vertical lines. You don't have to have bars that touch, but it's just quicker if they do. Okay. There we are, and I'm just going to put a title on it. I'll just call this lateness. I'll do. And that was for 3 marks. Okay, so question 10. Here is part of a bus timetable between Wigan and Bolton. So Wigan at the top, Bolton at the bottom. How many minutes should the 0720 bus take to go from Wigan to Lostock? So 7:20, so we're starting here, and we want to go from Wigan to Lostock down here. So 7:20 to 8:09. I'm actually going to use the fact that we've got 8 o'clock. That's handy, so I'm going to split that up. So from 7:20 to 8 o'clock, how many minutes is that? Well, if we can use the calculator, but I think it's easy to do it without. If I think 7:20, it'd be 10 minutes would be to 7:30, 7:40, 7:50, 7:60 doesn't exist because 7:60 would be 8 o'clock. So that was 10, 20, 30, 40. So this is 40 minutes. And then another 9 minutes to Lostock. So that's just going to be 49. Now there's another part down here. Alison goes from Blackrod to Bolton by bus. One day Alison leaves her house at 8 o'clock. She takes 7 minutes to walk to the bus stop in Blackrod. She takes 15 minutes to walk from the bus stop in Bolton to work. Alison needs to be at work for 9:20. Will Alison get to work for 9:20? You must show how you get your answer. And we've got 3 marks for this. All right, so she's leaving her house at 8 o'clock, but it takes her 7 minutes to walk to the bus stop. So she won't get to the bus stop until 08:07. Okay, so we want to see what time bus can she catch from Blackrod. So if she's going to get to Blackrod, let's move this down here, 8:07. So she'd miss the 7:49, but she can catch the 8:09. So she's going to be catching this one. And she's going to Bolton. So she's going to get off at 8:58. Okay, so 8:07, 8:58. She takes 15 minutes to walk from the bus stop in Bolton to work. So we want 08:58, and then we want to add on 15 minutes. So the best way to think of this is, well, to get from 8 o'clock to 9 o'clock, would just be 2 minutes. Yeah, 59.60. So that means if we take 2 minutes off of that, we would just have 13 minutes left to add on. So in other words, she would arrive at 09:13. And if we move this up, 09:13 is before 09:20. So would she get to work? Yes, she will. She'll have 7 minutes to spare. Okay. Question 11. 214 people go on a school trip. The people on the trip are either adults or children. There are 14 adults on the trip. 35% of the children on the trip are wearing a hat. Find the number of children on the trip who are not wearing a hat. Right, that sounds quite complicated. So I'm going to do this a bit like a probability tree. So we're going to start with 214 people, and they're either adults or children. And 14 adults on the trip. So if that's 14, the number of children must be 214 minus 14. And we don't need a calculator to tell us that that leaves us with 200 children. 35% of the children on the trip are wearing a hat. That's hat. That's no hat. So we want 35% of 200. 35% of 200. So we can do that with the calculator. So that's going to be 35 out of 100 times 200 is 70 children. They want us to find the number of children on the trip who are not wearing a hat. So that's going to be our 200 minus the ones that are wearing a hat, minus the 70. So 200 minus 70 leaves us with 130 children. 4 marks. How you want to lay this out is entirely up to you. You might want to do a table. You might just want to write workings out. I think it's good if you can have some sort of structure, something visual, so you can make sure you don't make any mistakes, or if you do, that it's easy to spot them. But exactly how you do it is up to you, as long as you get down to 130. Question 12. Work out 5/8 of 132. A few ways to do this. I find the easiest way is to do 5 divided by 8 times 132, and you get 82.5. Because of always means times. You might prefer to think of it as, well, if I want 5/8, maybe I'll do 1/8 first. So 1/8 of 132, or in other words, 132 divided by 8, which is 16.5. That's for 1/8. We want 5 of them. That would then give you 82.5. So a couple of different ways. Part B. Write the following fractions in order of size. Start with the smallest fraction. And this is for 2 marks. There we go. Right, well, we've got our calculator here. So all I'm going to do is type them straight in. So 3/8, just do 3 divided by 8, equals, so this is 0.375. If your calculator keeps it as a fraction, well, then you can convert it. You can use the SD button. So if it was showing a fraction, press it to get it as a decimal. So 9/32 or 30 seconds, 9 divided by 32 is 0.28125. Because then when I've got them all as decimals, it's going to be easy to compare these numbers. But again, if I use the SD button, if it was showing as a fraction, I'd just press that button there. 1/4, you should know this off by heart, is 0.25. and 21 divided by 64, 0.328125. So write the following fractions in order. Start with the smallest. So what's the smallest? 0.3, 0.28, 0.25, 0.32. So this is going to be the smallest one. What's the next smallest? This one, because 0.2. These are both 0.3s, but 0.32 is going to be smaller than 0.37. So it does say to write the fractions, so I want them in their original format. So it's going to be a quarter, then it's going to be 9 over 32, then 21 over 64, and finally 3/8. Question 13. A shop has 2 different special offers on milk. I've got milk, 2 pints, 75p a bottle. Pay for 2 bottles, get 1 bottle free. So if you're paying for 2, you're going to get the third one free. Well, here 4 pints, £1.28 a bottle. Pay for 1 bottle, get 1 bottle half price. So you buy 2 bottles, pay full price for the first one, half price for the second. Which offer gives the better value for money? You must show how you get your answer. And we got 4 marks for this question. So what we can do is we can work out the price for 1 pint on each one, and then we can compare those. So here we've got pay for 2 bottles, get 1 bottle free. So we're going to have 1 bottle, another bottle, and then the free bottle. So we've got 2 pints plus 2 pints plus 2 pints is 6 pints. But the amount we actually pay, we pay 75p for the first, 75p for the second, and then nothing for the third. So if we think of it as 75 plus 75, 150p, but you can think of that as £1.50. Okay. Now, that's for 6 pints. So what would the cost be for 1 pint? Well, it's going to be £1.50 divided by 6. Or we can leave the 150 there, divide it by 6. That means my answer is going to be in pence. So that's 25p, and that's per pint. Let's do a similar thing for the 4-pint bottle. So we've got pay for 1 bottle, get 1 bottle half price. So we've got 4 plus another 4. So that's going to be 8 pints. And we pay £1.28 for the first bottle. And the second one is half price. So £1.28 divided by 2, 0.64. Add that on to the £1.28. So that's £1.92 for 8 pints. So if we want the price per pint, we do £1.92 divided by 8, which gives us 0.24 or 24p. And again, that is per pint. Which offer gives the better value for money? Well, it's this one. It's going to be 4-pint bottle. And we can put 24p is less than 25p. So that's 4 marks. Okay, first bit of algebra. Question 14. Simplify 4c plus 7d plus 3c minus d. So we've got c's and we've got d's. Let's do the c's first. 4 of them plus 3 of them. We've got the calculator here, so 4 plus 3. That means we've got 7 c's. And the d's, we've got 7d and we subtract a d. So 7 minus 1 leaves us with 6d. Part B. Solve 5, 2m minus 6 equals 40. Well, we would have, because the number's next to the brackets, we've got an invisible multiply there. Now what you could do is you could multiply out the brackets. So 5 times 2m, 5 times minus 6. Actually, what I'm going to do is I'm going to divide by the 5 straight away. So that means that on the left, if I divide by 5, I'm left with just 2m minus 6. And on the right, I've got 40 divided by 5. 40 divided by 5 gives me 8. So I've got 2m minus 6 equals 8. We want, by solving it, it means find out what m equals. So I want to get rid of this minus 6. So if I move it to the other side, we do the opposite sign or opposite operation. We need to plus the 6. So we get that 2m is 8 plus 6, which is 14. Well, if that's 2m, 1m is going to be half. We're going to divide by 2. Because at the moment we're multiplying by 2, so the opposite, when we take it to the other side, divide by 2. 14 divided by 2 is 7. Okay, then we've got part C down here. There are X sweets in a box. There are Y sweets in a packet. Write an expression in terms of X and Y for the total number of sweets in 3 boxes and 2 packets. So 3 boxes, each box has got X. So it's going to be 3 times X in the boxes, and 2 packets, plus for the and, 2 packets with Y in each, so it's going to be 2 lots of Y. 2Y. 2 marks. Question 15. Hetvi asked her friends how many stickers they each have in their collection. Here are her results. 77, 86, 94, all of these different ones here. Show this information in a stem and leaf diagram. Well, they've drawn one for us down here. Now, when we do a stem and leaf diagram, we need to have them sorted in order. So what I'm going to do is I'm going to do a draft one here, practice one. So I'm copying theirs, but I'm going to not worry about the order of the numbers. I'm going to sort them when I do the final version. So if you're not sure about how a stem and leaf works, then the way it works is you put your tens or tens and hundreds on one side and the units on the other. So for example, if we want to write the number 77, we'd write 7 here. Actually, what have we got? 70, 80, 90s. Yeah, so 70 here and the 7 there. So that means 77. For 86, we'll put our 80 here and our 6 there. So 94 is going to be 9 tens, 4 units. 87, well, we've already got our 80s, so we don't need to write the 8 again, we just write 7. So this is telling us we've got 2 values, one that's 86 and one that's 87. So keep going. 71, so we can just write the 1. 98, just the 8. 74, put the 4. 103, so I'm going to put 10 and then just put the 3 here. 71. 85, so this goes here. 82, 84, 97, so down on this one. 91, 88, so extend these lines. 89 and 75. So we've got the values. So say we have to sort them now. So these are going to stay the same, our 7, 8, 9 and 10, but we want these in ascending order. So the smallest numbers we've got are the 1s, so we've got 1 and a 1, then a 4, 5, 7. So with the 8s, what's the smallest number we've got? We've got a 2, 4, then a 5, 2, 4, 5. Then we've got 6, 7, 8, 9. For the 9s, we've got 1, 4, 7, 8. And for the 10, we've just got one value. There you go. So this is now sorted. The key, all the key means, is we're explaining our notation. So we're just saying that 797 equals 77. That was for 3 marks. Now, for part B, find the median number of stickers. Okay, well, let's see how many we've got to start off with. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Well, if we want the median number, it would be the number we've got, so 17 plus 1 divided by 2th value. Let me explain what that means. So in other words, we want to find the middle value, so we take the number that we've got, add 1 to it, and divide it by 2. So if we've got 17, add 1, divide it by 2, that means that the middle value is the 9th value. It doesn't mean the answer is 9, but it's the 9th value. Now, because we've done our stem and leaf diagram, we've sorted the numbers. So if we want to find the 9th value, we just count. 1, 2, 3, 4, 5, 6, 7, 8, 9. But it's not just 6, it's 86. Question 16. Water flows through each of the pipes that fill a lake at the same rate. It takes 4 of the pipes 12 hours to fill the lake. Work out how many hours it would take 6 pipes to fill 1/4 of the lake. And this is for 3 marks. Okay, lots of words, sounds quite confusing. So let's think, well, how much is there in the lake in total? I mean, we haven't got litres, but think, well, how many hours worth of water have we got? Well, we've got 4 of the pipes working for 12 hours each. So that's 4 lots of 12, because the first pipe is working for 12 hours, and the next pipe is working for 12 hours, the third is working for 12, and the fourth is working for 12. So in total, we've got 4 times 12, which is 48 hours. Okay. Right, but work out how many hours it would take 6 pipes to fill 1/4 of the lake. So we only want 1/4 of that. So actually what we can do is say 48 divided by 4. So we're going to go backwards. Well, we multiplied by 4, so if we divide it by 4, it should take us back to 12 hours. Okay, so we want 12 hours worth of water. Now we've got 6 pipes. So 12 hours, we're going to divide it by the 6 pipes. And that means it's going to take 2 hours. Okay, they confused it a little bit by talking about only filling 1/4 of the lake. So it makes it harder to compare. But if you think about how much you'd get in the lake in total, the fact that we've got 6 pipes, well, that means that it's going to be quicker than doing it with 4 pipes. But remember, we're only doing 1/4 of the lake. Question 17. The table shows information about the heights of 80 teenagers. And we've got that there were 8 teenagers between 150 and 160 centimetres, 14 of them between 160 and 170, and so on. Work out an estimate for the mean height of the teenagers. We've got 3 marks for this. So the reason it's an estimate is because we don't know the exact heights of these children. We've just got, or teenagers, we've got a range. So what we have to do is assume that all 8 of these are right in the middle of this range. And all 14 of these are right in the middle. So we want to work out the midpoints. Halfway between 150 and 160, well, you might be able to see, oh, well, it's going to be 155. But if you can't, what you can do is take the two values, add them together, and divide them by 2. And if you do that for all of them, we'd see for the next one, we'd get a midpoint of 165, 175, 185, and 195. So now we can work with the midpoints, so we don't care about these anymore. If you think when we're working out the mean is worked out by getting the total and dividing it by the frequency. But it's always good to think, what is this total? What we're talking about? Well, the total would be the total height of all 80 teenagers. So if we want to work out that height, we're going to have to work them out for each range first of all. So if we've got 8 teenagers that are 155 centimetres, we're going to need to multiply those together. So that means this range, we've got a total of 1,240 centimetres. And for this range, it's going to be 14 times 165, and the same all the way down. So let's do those ones. 14 times 165 is 2,310 centimetres. 24 times 175 is 4,200 centimetres. It's this step that can be a bit more confusing, doing it per sort of category or range. But then, hopefully it makes sense, because if we add these all up, it's going to give us the total height of all of the teenagers. So we get 14,080. So that's going to be our total up here. That's centimetres. Well, what's our frequency? Well, it's the total number of teenagers. So we can add these all up, but actually they've told us that there's 80 of them. So I'm just going to divide that by 80. Now before I press equals, it's always good to think, what should the mean be? So we can do a check as to whether it looks reasonable. Well, if these were the values, we're expecting it's going to be somewhere in the middle. So it's probably going to be around 170 something, maybe between 175 and 185 looking at this. So let's see what we get. 176. So now that I've got that, because I've sort of looked at what I thought was reasonable, I can just go with the answer. If I got something, well, certainly if I got something smaller than 150 or bigger than 200, I know it's wrong because it's outside the range. Okay, but this is somewhere in the middle. That looks sensible. Question 18. The scatter graph shows information about the amount of rainfall in millimetres and the number of hours of sunshine for each of 10 English towns on the same day. So if we pick a value, this one for example, I'll move it up. What this is telling us is that this town had 8 hours of sunshine and between 2 and 4, so this is going to be, and 3 millimetres of rainfall. Okay, but we've got 10 different towns on here. We're told one of the points is an outlier. Write down the coordinates of this point. So an outlier means it doesn't really fit the same pattern as all the others. Right, well, these seem to be fairly clustered together. This one looks a little bit odd. So that's going to be our outlier. So the coordinate will go across first, so we've got 2, and then along, so that would be 1. So the coordinate would be 2, 1. And I've got another part to this question. So ignoring the outlier, describe the relationship between the amount of rainfall and the number of hours of sunshine. Okay, so what I'm going to do is I'm going to draw a line of best fit. They haven't asked us to do it, but this will help me to see the overall sort of pattern or relationship of these values. So they're all kind of sloping down to the right, and I want to do a line that goes through the values, follows the overall sort of pattern or overall trend. Might go through some of the values, might not, doesn't matter. We want roughly the same on one side to the other. Now I can see this line now is very clearly sloping down, so that means we've got a negative correlation. So as my x values are increasing, going up, my y values are decreasing, coming down. So if we go back to here, ignoring the outline, describe the relationship between the amount of rainfall and number of hours of sunshine. We could do that in words, or we could just say negative correlation. If you were to use words, it would be something like the amount of rainfall increases as the amount of sunshine reduces, something like that. Okay, but just saying it's a negative correlation should be enough. On the same day, in another English town, there were 7 hours of sunshine. Using the scatter graph, estimate the amount of rainfall in this town on this day. Okay, so this is really helpful that we've actually done a line of best fit, because that's what they want us to do. So we want 7 hours of sunshine, we want to find out how much rainfall. So 7 hours of sunshine. So here's 6, here's 8, 7's going to be here. So if we do a line across, it meets here. We then do a line down, which brings us out here between 3 and 4. Now we've got 5 little boxes between 1 millimetre of rainfall. So if we do, I suppose 1 divided by 5, it's going to tell us what each of these little boxes is worth. So 1 divided by 5, or a fifth, is 0.2. So that means that that would be 3.2. This is going to be 3.4. So you couldn't see that on there, I just realised. So we worked out what each of the little boxes is worth, which is 1/5 or 0.2. So this is 3. The first box would be 3.2. The next box will be 3.4. I'm just going to put that in our answer box on here. Question 19. The front elevation and the plan of a solid are shown on the grid. On the grid, draw the side elevation of the solid from the direction of the arrow. Okay, right. So this is front, so we're looking straight on at the building here. This is the plan, looking bird's eye, looking straight down onto it. So what's the side going to look at? So looking from this side. So if you think we're looking at it from this angle, so we would see, well, it would be 1, 2, 3, 4, 5 boxes high. So let's start it here. We'll go 1, 2, 3, 4, 5. And how many across? Well, if we're looking from this angle, we would see 1, 2, 3 boxes across. So it's basically going to be a rectangle like that. But what we would see is, well, we'd probably see this point here where the slope starts. So after one box, And then after 2 more, we'd see this bit here where the top stops and then the next bit comes up. So we'd also see this line here. So that would be our side elevation. We wouldn't see this point here because it would be hidden by this sloping roof, but we'd see here, here, and up at the top. And we know from the plan that it's 3 boxes across. And that's for 2 marks. Question 20. Here are the first 5 terms of an arithmetic sequence. That means that the value goes up by the same amount each time. Find an expression in terms of n for the nth term of this sequence. So let's see what they're increasing by first of all. So what we can do, if we take this value and subtract the first one, so 13 minus 7, see that's going up by 6. And let's just check these ones, 19 minus 13, yeah, that's going up by 6. 19 plus 6 gives 25, plus 6, 31, yeah, so it's just going up by 6 each time. Now, if we're thinking about the nth term, so this is the first term, this is the second, third, fourth, fifth. So we want to write an expression that tells us what it is for us to work out what the nth term would be. Now, once you've found what the amount you're adding it to, let me start again. When you found out the amount that the numbers are increasing by each time, you want to multiply that by n. So, for example, we're going to write 6n. Now, for this first value, if we did 6n, 6 times 1, we'd get 6. We would need to increase it 1 to get up to 7. So let's test that here. If we did, it's the second value, so 6 times 2, well, if we get the calculator, 6 times 2 is 12. We need to get to 13, so again, we need to add on 1. Oh, I did it twice. 12 plus 1, 13. Okay. And let's test it for these ones as well. So for the third term, 6n, so 6 times 3 is 18. Add on the 1, we get 19. So this is the expression we want. Now, we're told the nth term of a different sequence is 8 minus 6n. Is minus 58 a term of this sequence? You must show how you get your answer. And we've got 2 marks for this. Okay, so what we're saying, if it was true, we would be saying that 8 minus 6n equals minus 58. So if we can solve this and n is a whole number, well then yes, it's possible. If n's not a whole number, then it doesn't work. Right, now, this looks a little bit messy because I've got minus 58 here. So what I want to do is I can reverse, no, what should I do? Yeah, I want to make this a positive 58. So I'm going to swap sides. So move everything here to that side and everything here to that side. So if I move minus 58 to this side, it becomes plus 58. And if I move positive 8 to the other side, it becomes minus 8. And if I move minus 6n to the other side, it becomes a positive 6n. So I've just swapped them over. So what we're saying is 8 minus 6n equals minus 58 is the same as positive 58 equals 6n minus 8. Now, I'm going to try and solve this for n. So I want to move my minus 8 across. So that's going to become a plus 8. So I end up with 58 plus 8 equals 6n. And 58 plus 8 is 66 equals 6n. Now, it might seem like I'm swapping these over lots of times, and I hope it's not confusing it, but I'm going to get my n's on the other side, so I'm going to say, well, 6n equals 66. I've just swapped places. Because what I want to find out is what's just one n. So I divide by the 6, so divide it by 6. So 66 divided by 6, and we get n equals 11. Now, that's a whole number, so that's fine. So the nth term is minus 58 a term of the sequence? Yes, it is, because we've got a whole number here. Different ways of doing this. You might, as I say, might find this confusing, swapping over the signs. You might want to just try and solve it and keep the negatives in there, but just be careful if you're doing that you don't get mixed up with double negatives and things like that. Question 21. The diagram shows a plan of Jason's garden. ABCO and DEFO are rectangles. CDO is a right angle triangle. Okay. And AFO is a sector of a circle with centre O, and angle AOF equals 90 degrees. So we've got a right angle here as well. Okay. And we've got some measurements on here. Jason is going to cover his garden with grass seed. Each bag of grass seed covers 14 metres squared of garden. Each bag of grass seed costs £10.95p. Work out how much it will cost Jason to buy all the bags of grass seed he needs. Right, so for us to find out the cost, we want to know how many bags, and to find out how many bags, we need to know what's the total area of his garden. Now, they've split it nicely into 4 different sections for us, so let's work them out in those separate sections. So the area of this rectangle is going to be the length times the width. So 11 times 7 which is 77 metres squared. Now this one should be equally straightforward. We've got the length and the width, so the area is going to be 9 times 7, which is 63 metres squared. Now next easiest is probably the triangle. Now I'll do this over here. The area of a triangle is equal to a half times the base times the height. So half, let's call it 0.5, times the base. Well, let's imagine that this triangle is the other way. Let's say this is the base and this is the height. It doesn't matter if it's top to bottom or bottom to top. So this distance here is 11, and the height down here is 9. So 0.5 times 11 times 9 is 49.5 metres squared. Now we just need this area. Okay, so it says this is a sector of a circle. Well, the area of a circle is pi r squared, where r is the radius, which in this case is 7 metres. So it's going to be pi, we can use our pi button on our calculator, so it's going to be pi times 7 squared. So pi is down here, so we need to do shift pi times 7 squared, 153.93804. But this is only a quarter of a circle. So we want to divide that by 4. Which gives us 38.4845. I'm going to round that to 2 decimal places. So 38.48 meters squared. Okay, so the total area, we're going to add them all together now. So it's going to be our 38.48 plus 77 plus 63 plus 49.5. If we do all of that, actually I'll use the rounded value on here for now, because we're going to have to round it to find out how many bags of seed we need, so it's alright to round it in this case. If not, you can keep all the values in there, that's fine. So we get a total of 227.98 meters squared. That's the area. Each bag of grass seed covers 14 meters squared, so we want to divide 227.98 by 14. And we get 16.28 bags needed. But of course we can't buy 0.28 of a bag, so we're going to need 17 bags, and we'll have a bit left over. Right, so 17 bags, each one costs £10.95, so 17 lots of £10.95 is £186.15. And that's 5 marks. Question 22. We've got a triangle here. In fact, we've got a right angle triangle. We've got one angle. We've got the hypotenuse, and we've got x centimetres here. Work out the value of x, which is this length. Give your answer correct to 3 significant figures. Okay, so we've got a right angle triangle, we've got one angle, we've got one length, we want to find another length. We're going to need to use some trigonometry. So this is our SOHCAHTOA. Okay, we're going to work out which one of these we're going to need. So the longest side of the diagonal is always going to be the hypotenuse. This is the angle we've got, so the one opposite that angle is the opposite, and the other one must be the adjacent. So we've got the hypotenuse, and we want to find out the adjacent. So we're looking at these two letters, so we want A and H, like that one, so it's going to be this one. So we're going to need cos of the angle, or cos of x, is equal to the adjacent over the hypotenuse. Now, if this doesn't mean... no, it doesn't. Sorry, cos of 53, that's the angle, is equal to the adjacent over the hypotenuse. Okay, and yeah, we'll leave it like that for now. If this doesn't mean anything to you, then you need to go and swat up on some trigonometry. Okay, but hopefully this will mean something, especially now that I've written the angle in. Apologies if I've confused you by trying to do the cos of a length. That would make no sense at all. Okay, so we know cos 53 equals adjacent over the hypotenuse. In fact, cos 53, we know that the adjacent, we can call that x now, and the hypotenuse is 14.5. We want to find what x is, so do the opposite of dividing, we're going to multiply by 14.5. So another way of saying that is x equals 14.5 times cos of 53. We can do that directly in our calculator. 14.5 times cos 53, and we get 8.726317, blah blah blah. Have they said to 3 significant figures? So 1, 2, 3. So we look at the next digit. It's 5 or more. We need to round it up. So it's going to be 8.73 centimetres. Okay, question 23. This is for 3 marks. Alette invests £7,000 for 2 years in an account paying compound interest. In the first year, the rate of interest is 3%. In the second year, the rate of interest is 1.5%. Work out the value of Ella's investment at the end of 2 years. Right, so we've got £7,000. Now for the first year, it's increasing by 3%. So 3%, 3 out of 100 as a decimal is 0.03. So it's going to increase by 3%, which means we want 103%, which is going to be 1.03. So if we multiply this by 1.03, it's going to increase that by 3%. So it's working at 3%, but at the same time it's adding it on to the original amount. Now I'm not going to work that out straight away, because I'm going to do this in sort of one step. I'm going to work out what we'd need for the second year. So we're going to do something similar, but for the second year it's 1.5%. Well, 1.5 out of 100 is 0.015. So 101.5% would be 1.015. So we can then multiply this by 1.015 and do it all in one go. So let's do it down here so you can see what's happening. 7,000 times 1.03. That's what the investment's worth after the first year. So 3% is the extra £210. Then we multiply that by 1.015. So it's going to work out the 1.5% and add that on, which gives us £7,318 and 15p, which we can write down here. Okay, question 24. Here is the graph of y equals x squared minus 6x plus 4. Okay. Now we've got a few questions for this over here. Write down the y-intercept of the graph y equals x squared minus 6x plus 4. So the y-intercept just means where does it cross the y-axis? Well, it's here at 4. So that's a nice straightforward one. Okay, part B. Write down the coordinates of the turning point of the graph of y equals x squared minus 6x plus 4. So the turning point means when does it stop going down and start going up? Or the other way around, when does it stop going up and start going down? So that's right down here. So we go up, so it's going to be 3. And go across, that's going to be minus 5. Okay. So this question at first might have looked a bit scary, but actually doing this you can see it's not too bad. We're just reading off of the graph. Use the graph to find estimates for the roots of x squared minus 6x plus 4 equals 0. All it means by the roots are, what does x equal? And because it's a quadratic, because it's got x squared, we're going to have 2 different values. Okay. And that basically means, where is it cutting the x-axis? So here and here. So this is 0, that's 1. This would be 0.5, 0.6, 0.7, that would be 0.8. It's halfway in between, so it's going to be 0.75. So that's one of my values. And the other one is going to be similarly over here. So 5.1, 5.2, that would be 5.3. So right in the middle, it's going to be 5.25. So it could very easily put people off, but actually there's no reason why you can't just pick those straight off. We haven't had to do any algebra, any clever calculations. You just need to know what to look for. Okay, question 25. Find the value of the reciprocal of 0.8. So again, this isn't hard to do, you just need to know what reciprocal means. If you don't, you're about to find out. It just means 1 divided by the value. And we've got our calculator, so 1 divided by 0.8, 1.25. X equals 4,700 to correct to 2 significant figures. So like the second significant figure is in the hundreds. So basically you could say to the nearest 100. Complete the error interval for x. By error interval, it means this has been rounded. What's the smallest and biggest value it could actually be that still rounds to 4,700? Well, if it's the nearest 100, well, it can definitely be smaller than 4,700, so 4,600 and something. If it was, for example, 4,630, well, rounding to the nearest 100, it would go down to 4,600. So that's too small, that's not going to work. What's the first time that it would round up to 4,700? Well, that would be 4,650. Because we'd look at the 5 and say, right, we need to round up to 4,700. Similarly, now if you notice it says less than or equal to, so it can be equal to this value. Now for the top value, the top bound, it's just less than. So it's going to be the same sort of thing at the top. So 4,750. Now you might be thinking, but with the 5, we would round up to 4,800. We would if it said equal to, but this is saying less than 4,750. So basically it's 4,749.999, as many times as you want. Anything smaller than 4,750 would still round to 4,700. And finally, question 26. The population of a town increased by 9% between 2018 and 2019. The population in 2019 was 165,680. Calculate the population in 2018. Right, so this figure, this 165,680, that has already been increased by 9%, so that relates to 109%. We want to find what was 100% in 2018. So the best way to do that is, first of all, divide it by 109. That will tell us how many people equate to 1%. So we get 1,520. That's 1%. So we want 100%, so we just multiply by 100. And we get 152,000. If you tried working out 9% of this value and then taking it off, you won't get the right answer. The only way to do it is to treat this as 109%, divide by the 109. You could do it in one go. You could divide by 109 and multiply by 100. without doing it in 2 steps like this. But I think this is a nice way to think of it. We're finding 1% and then we're using that to find the original 100%. So that's the end of the paper. Hope you found it not too challenging. Please do subscribe to the channel, like the video, turn on your notifications so you find out when I upload more videos, and I look forward to seeing you again soon. Thank you.